So Mod 2.1 is about quantities and covariation of quantities, how to do two quantities affect one another. So let's just start with problem number 1. It says Arizona State University graduate Desiree Linden won the Boston Marathon in 2018. She began the 26.2-mile race with a slow pace due to wind and rain. After completing the first half of the race, she increased her pace, completing the marathon in a time of 2 hours, 39 minutes, and 54 seconds. Part A says, identify at least two distances in this situation that are constant. That is, those distances, the values don't vary. And be sure to specify the distance, its values, and the unit of measurement. Yes?
The length of the marathon.
Exactly. Okay, so that's one of the distances. So I'm going to make a little diagram. Well, let's just, they have one down at the bottom. So let's just make like a little bullet list here. So the marathon length is 1. That doesn't change. Can anybody tell me another thing that doesn't change? What is a distance in this situation that is constant that doesn't change? Can anybody come up with another distance that doesn't change? Yes. Exactly, that halfway point, right? And so we're going to say the halfway point. Now it says to be sure to specify the distance, its value, and the unit of measurement. Half of 26.2 is 13.1. 13.1 miles is your halfway point. So those are distances that never vary. Now let's take a look at part B. It says identify at least two distances in this situation that do vary. Can anybody come up with one that does vary? What do you think? Well, we want distances that vary. Now the time, of course, depending on where we're at in that time, that does vary. Anthony, did you have an idea as to what is a distance that's going to be varying?
I mean, the pace at which she runs each half the race.
Well, the pace would be a rate. So if we're talking about distance, but I think you're on the right track. What I'm thinking is we could always look at how far away she is from the beginning of the race. So, you know, the length, the place she's at in the race. So we could call that, I guess, her distance from the start, I guess, would be a place to talk about. Now it says, for each distance, be sure to specify the unit of measure and where the measurement begins. So if it's the distance from the start, we could just call it X. And of course, it should be miles, unless we wanted to convert it to feet or something like that. Anybody else think of another way that we could look at a distance that is changing as she runs? Yes. The distance from the finish, exactly. Now here's where I'm going to use the picture. And it would actually be, if we still think of the distance from the start as X, the distance from the finish would be 26.2 minus X, okay? Now it says, when Desiree has run 6 miles from the starting line of the 26.2 mile race, how far is she from the finish line? So if we think as this being 6, this total distance here is 26.2. So how do we find Desiree's position? How do we find this? Yeah, you're just going to subtract. And so that would be 26, yep, 26.2 minus 6, or 20.2 miles. And that kind of illustrates see what we did here. That's why if we call the distance from the start x, the distance from the end will always be 26.2 minus that x. And then let's move on to D. When Desiree has run 22 miles from the start line, how far is she from the finish line? And indicate Desiree's approximate position on this illustration. So you'll notice I'm closer to the finish than I am from the start. And so if we did that same thing, 26.2 minus 22, yep, we get 4.2 miles. And then E says, as Desiree's distance from the starting line increases, how does her distance from the finish change? Yeah, so as that is a variation, as one is going to be increasing. So when she's here, that's there, but when she's here, that got smaller. When she's here, that got smaller. So we would say the distance would decrease. So one thing you're going to notice about this iMath course as you go through it, the iMath course is not necessarily going to be super challenging mathematical, but they want you to really start thinking abstractly about how things are related and how to represent quantities and variables and things of that sort. Anybody have any questions about what we have so far on this one? Okay. So now let's look at, I'm just trying to see how far we're going to get here. I do not know, but we'll do our best. Okay. So let's look at 2A. It says represent each of the following on the given illustration. The total race length using a solid line segment with bars at each end. So mathematically, you would have that. You would put bars on the end in a straight line. That's your 26.2. And then 2 says Desiree's distance from the starting line using a dash segment with a dot on one end to indicate that the measurement begins at the starting line, and an arrow on the other end to represent the direction of measurement. So what they want there is like that. Okay. And then 3 says Desiree's distance from the finish line using a dash line segment with a dot on one end indicate where the measurement begins, and an arrow on the left end to represent the direction of the measurement. And there is a way to make Notability make dash lines, so if you can do that, feel free to do that. Okay, so then let's take a look at 2B. It says, as Desiree runs the race, how do each of the following vary? So Desiree's distance from the finish line is decreasing. Desiree's distance from the start line is increasing. The lengths of the line segments you drew in part A, they always add to the total 26.2. So, and then I had used a variable earlier. That's what they're getting at for part C. It says in mathematics, it is useful to use a letter or variable to represent the value of the quantity when that value varies. If we let the variable x represent Desiree's distance from the starting line in miles, then the value of the expression 26.2 minus x, what does that represent? That would be here. Okay. And it represents the, how would you say that? The distance. So the distance from Desiree to the finish. And then we've labeled it, if you'll notice, just label it like I have done up here. That would be our x, and that would be our 26.2 minus x. So that's done. What values can x assume to take on in this situation? Give 3 examples and describe all possible values. So I'm going to kind of jump ahead. She could be 1 mile from the start. So x is the distance from the start to Desiree. And so she could be 1 mile from the start. X could be 1 mile. X could be 10 miles. And X could be 26.2 miles. We kind of think of that as the possibilities of X as a domain. And we're going to write that as it can be anything from, she could be standing on that starting line and not moved, and she can go all the way up to 26.2 miles. In pre-calc, we want to use a bracket to say that is a valid option. So that means 0 and 26.2 are valid options. In this interval notation, which we will touch upon more as we go, this is the start of the interval, this is the end of the interval, and it can be any decimal value in between. So interval notation can only be used if you can use every single value from A to B. And so that's what that looks like, okay? And then F and G. True or false, the value of 26.2 minus X varies as Desiree runs the race. Of course that's true. That's going to be changing as we run that race, as she runs that race. And then G, the expression 26.2 minus X represents Desiree's distance from the finish line in terms of her distance from the starting line. And so in terms of, in this situation, means that the same variable we see in one appears in the other, and they are related. So that's what that means, and that would be a true. Let's see. Okay. Because I would like you to be able to play a little bit in iMath right now, please turn this in where it sets. Please make sure that you turn this into the mod 2 -1i. If we have time, we'll come revisit it. But for now, if you could please turn this in. And then if you could go into your iMath that you have started today, where it says online homework, and then there is like an introduction that you want to get started on.